Okay, in this video we're going to take a look at a quantity called equivalent resistance. What we've looked at so far is series and parallel rules for how components put together in series or parallel can affect the total resistance of the circuit depending on how you connect them. So equivalent resistance comes into play when we have multiple components both in series and parallel, and we want to figure out what's the effect of those connections on the circuit and how current flows. So let's start with some very simple examples of equivalent resistance. Let's say I have two resistors that are 50 ohms and I connect them together in series. Well, based upon the series rules for resistance, we would say the total resistance of those two is just the resistance of their individuals added together, and we could say the total resistance is 100 ohms. So if I were to take a single resistor that was 100 ohms and replace the 250s in series, there's no difference. This is equivalent to this, right? They're the same thing. They would have the same effect on the current that's flowing through that circuit. Another way we could look at this is with parallel connections. If I had two resistors in parallel, let's just say they had a resistance of 4 ohms each, and I said, what's the effect of these two in parallel, or what's their total resistance? We would say, well, using the parallel rule, 1 over RT is equal to 1 over R1 plus 1 over R2. Or a quarter plus a quarter, which is equal to a half. If 1 over RT is equal to a half, RT is equal to 2 ohms. So if I were to take these two 4 ohms in parallel and replace them with a single 2 ohm resistor, it would have the same effect on the circuit. So these two are equivalent. And that's where the idea of equivalent resistance comes in. Now, where it becomes more important is when we have what we call combination circuits, or circuits that have some things in parallel and some things in series. So let's go with a new color and let's look at a more complicated example. So let's take a combo circuit that has one resistor in series with two other resistors that are in parallel. So notice, I can't describe this circuit as either series or parallel because this component is in series with both of these, but these are in parallel with one another. So when we have combo circuits, we need to be able to take these and rewrite these as a single circuit with one equivalent resistance, or the equivalent of putting all these together in series and parallel has a single total resistance that we can be able to find. All right, so let's look at how we do that. So in order to set that up, we need to break this down piece by piece. So first, take a look at which components are kind of isolated together in either parallel or series against the other one. And if I look, this one is in series with both of these, but these two are isolated in parallel together. Let's give these some values. Let's say this is a 10 ohm, and this is a 15 ohm, and this is a 25 ohm. So the first thing I want to do is determine what is the total resistance of these two in parallel and replace that with one single resistor. So in order to do that, I use my parallel rule, and I'm going to call this the total resistance of the second and the third resistor, RT2-3. So let's set this up. So 1 divided by 15 plus 1 divided by 25, and I take the inverse of that, gives me 9.375. So the total resistance of these two in parallel with one another is 9.375 ohms. Okay? So now I can replace these two in parallel connections with one single 9.375 ohm connection. So let's redraw that. So I still have my 10 ohm in series, but now I'm going to replace those other two with a single 9.375 ohm resistor. And I'm left with two resistors now in series with one another. So what's the total resistance of these two? Well, the total resistance in series just adds together. So this new total resistance of these two can be rewritten as a single resistor with a resistance of 19.375 ohms. So this is the equivalent resistance of the combo circuit of 110 ohm in parallel or in series with a 15 and 25 in parallel. So take it step by step, simplify them down until you get one single resistance that represents the whole circuit. And that's how you find equivalent resistance.